Welcome to this week's edition of Pale Blue Dot Narrative. Today, we explore 3 stories that connect the ground beneath our feet to the far reaches of space. We begin in our cities, where rising temperatures and concrete landscapes are quietly turning urban spaces into heat traps. As climate extremes grow more frequent, we ask, could the urban heat island effect be setting the stage for more devastating wildfires? Next, we shift to the fast-approaching horizon of wireless communication. The era of 6G is beginning to take shape, promising speeds and capabilities that could redefine how we interact with data, machines, and each other. We'll explore what sets 6G apart from 5G and why it's more than just a technical upgrade. And finally, we head into space. A recent observation by the James Webb Space Telescope has revealed new details about Asteroid 2024, YR4, a new rocky visitor that recently brushed past the Moon. What does this close encounter mean for Earth? And why does the growing interest in cis-lunar space matter more now than ever? Stay with us as we unravel the science shaping tomorrow, from heat waves on Earth to hyperspeed in the sky and celestial near misses in our cosmic backyard. When we think of wildfires, we often picture remote forests, dry valleys, and rugged landscapes far from city life. But that image is rapidly becoming outdated. Increasingly, wildfires are reaching into suburban neighborhoods, crossing highways, and brushing the edges of major cities. And while climate change, drought, and land management are well-known culprits, there's another factor that's less visible but no less dangerous. It's called the urban heat island effect. This phenomenon occurs when cities become significantly warmer than their rural surroundings. Asphalt, concrete, steel, and glass, all materials we use to build cities, absorb heat during the day and release it slowly at night. That means urban areas stay hotter for longer, especially during summer. And this heat isn't just uncomfortable, it's flammable. As cities heat up, so does the vegetation within them. Lawns, street trees, parks, and even rooftop gardens lose moisture more quickly. The result? Urban environments that are drier, more brittle, and much more vulnerable to ignition. At the same time, the stress on city infrastructure spikes. Power lines sag under higher loads. Transformers overheat. Air conditioning systems run over time. And when electrical systems fail in heat wave conditions, they often spark in wildfire-prone regions. That spark is all it takes. Urban layout compounds. The problem? Narrow streets lined with tall buildings trap heat like a canyon. The same architecture that blocks cooling winds can also trap smoke and radiant heat during a fire, creating dangerous conditions for both residents and firefighters, and perhaps most crucially, the expansion of cities into what we call the Wildland-Urban interface, where homes meet forests or grasslands, is placing more people and structures directly in the path of potential wildfire. The urban heat island doesn't cause these fires, but it makes the ingredients for fire, heat, dryness, and ignition, more readily available and more intense. Fortunately, cities are not powerless. Urban planners and climate scientists are now focusing on mitigation strategies, installing reflective rooftops, planting fire-resistant vegetation, creating defensible green space buffers, and updating building codes to account for fire risk. Because in the age of climate extremes, cities must evolve. They must become not just livable, but resilient. And that means understanding that fire risk doesn't stop at the forest edge. It now lives on the city street too. Today, we're peering into the next wireless revolution, 6G, a network not just built for speed, but designed to be intelligent, adaptive, and deeply integrated with the world around us. For most of us, 5G is still rolling out. It brought us faster downloads, more reliable streaming, and low-latency experiences. But 6G is a whole different paradigm. It's not just the next version of 5G, it's a reimagining of what a network can do. Let's start with what makes 6G different. While 5G gave us gigabit speeds and near-instant connections, 6G aims to multiply those speeds by 100, reduce latency to just 100 microseconds, and go far beyond just linking devices. It's about embedding intelligence and awareness into the network itself. Imagine a system that doesn't just carry data, but learns from it, predicts what's needed, and adapts in real time. And this transformation has been quietly building behind the scenes. Since around 2020, governments, tech companies, and researchers across the globe have been sketching out the 6G vision, from South Korea to the United States, and from the European Union to Japan and China. There's a massive coordinated push to define what 6G will be and how it will function by the end of this decade. So what does the 6G network actually look like? Think of it as a multi-layered nervous system for the planet. In the sky, you have got satellites and high-altitude platforms. In the atmosphere, drones and aerial relays. On the ground, reconfigurable smart surfaces that reflect and amplify signals, and underground or underwater sensors connected to the same system. Everything works together in a seamless space-space air-ground underwater network. At its core, 6G is AI native. That means artificial intelligence isn't just tacked on, it's built into the network's design. It enables real-time decision-making, traffic prediction, and autonomous network control. Add to that, terahertz communication for ultra-fast data transfer, and edge computing for processing data closer to where it's generated. And you've got a network that's faster, smarter, and more responsive than anything before it. And what will we do with all that power? Here are just a few of the transformative use cases 6G is expected to enable. First, holographic telepresence, full-body, 3D real-time holograms that let you meet and collaborate virtually with someone across the globe as if they are in the same room. Second, brain-computer interfaces, devices that allow neural communication directly with cloud systems, opening up new frontiers in accessibility, communication, and human augmentation. Third, real-time digital twins of entire cities, factories, or even human bodies, updating live based on sensor input and helping us manage everything from energy grids to healthcare in ways we never thought possible. Then there's autonomous mobility, fleets of vehicles, drones, and robots that communicate with each other instantly, coordinating without human intervention. And yes, remote surgery with tactile feedback where a surgeon can operate thousands of miles away, feeling what their instruments feel in real time. This isn't science fiction. It's what 6G is being built for. Of course, we are not there yet. Major technical and regulatory challenges remain, like managing the terahertz spectrum, ensuring security in an AI-driven system, and building the infrastructure to support all this innovation globally. But the path is set. By 2030, 6G could begin to reshape our digital lives. So when you hear about 6G, don't think of it as just faster internet. Think of it as the foundation of a truly connected, intelligent world. A world where communication, computation, and perception are all part of the same invisible, intelligent web. There is a new space rock making waves in the astronomical community. Asteroid 2024 YR4. It's relatively small, about 60 meters across, but it now carries a slightly increased possibility of impacting on December 22, 2032, not on Earth, but on the Moon. Thanks to the James Webb Space Telescope, scientists have been able to track the asteroid far beyond the orbit of Mars, about 1.8 astronomical units from the Sun. This is well past the range of Earth-based telescopes, but JWST's infrared eyes picked it up clearly in May 2025. The data it collected helped NASA's Jet Propulsion Laboratory reduced the uncertainty in the asteroid's orbit by nearly 20%. The result, the estimated probability of a lunar impact, rose from 3.8% to 4.3%. That may sound like a small change, but in the world of orbital predictions, it's enough to take notice. So, what happens if it does hit the Moon? A collision with that kind of mass and speed would release between 5 and 6.5 megatons of energy, roughly 300 times the power of the Hiroshima bomb. It would excavate a crater about half a kilometer to a full kilometer across. That would be a visible, permanent mark on the Moon's surface, potentially one of the newest craters in human history. But the bigger concern lies not in the crater itself, but in what's launched outward. Such an impact could eject up to 100 million kilograms of lunar debris. Some of that, perhaps 10%, could enter what we call cis-lunar space. This is the region between Earth and the Moon, and it's becoming a very busy place. We've got satellites, upcoming crewed missions, and infrastructure like NASA's Lunar Gateway, all preparing to occupy this domain. If lunar debris starts floating through cis-lunar space, it could increase micrometeoroid activity and threaten orbital assets for years, maybe even decades. Here's the good news: Earth is not in danger. JWST's precision measurements ruled out any chance that 2024 YR4 could hit our planet. So we're safe down here. But what happens on or around the Moon can still have consequences for us, especially as we expand our presence beyond low Earth orbit. Cis-lunar space is no longer just an expanse of emptiness between us and the Moon. It's an emergent highway of human activity, and any disruption, natural or otherwise, matters. Looking ahead, we won't be able to observe asteroid YR4 again until December 2028, when it passes closer to Earth. That flyby will give scientists another opportunity to refine its trajectory before the 2032 lunar encounter. Until then, we will keep watching the simulations and running the numbers, because in space, even a 4% chance is worth preparing for. As we wrap up today's stories, remind us how deeply interconnected our world is. Technologically, environmentally, and cosmically. Urban heat islands aren't just a local phenomenon. They're a signal of how we shape our environments and the unintended consequences that follow. The promise of 6G, meanwhile, shows us how rapidly innovation is moving, pushing the boundaries of what connectivity can enable. And far above us, the quiet paths of asteroid 2024 YR4 serves as a cosmic nudge, a reminder that space isn't empty, and our awareness of it is still evolving. Thank you for joining us in exploring these intersections of science and society. Until next time, stay inspired and never stop exploring our extraordinary pale blue dot.